Assalamu alaikum warahmatullahi wabarakatuh. Today my lab is about the gram staining from traditional lenses to AI vision. This lab is prepared by me. My name is Nabil Muhammad Ali. I work at the University of Basra College of Medicine, Department of Medical Microbiology. Today we are not just learning how to stain bacteria. We are witnessing how the microscope, which is a 140-year-old microbiological masterpiece, speaks the digital language of AI. Our goal is to move beyond memorization and master the art of intelligent diagnosis. Now, as a student, imagine if all bacteria disappear. What would happen if all bacteria vanish instantly? If you think that all bacteria may vanish instantly, you will not think about the diseases. You will think about the good thing that my bacteria do. For example, we have oxygen production. Photosynthetic bacteria does this. We have digestion, some microbiome in human and animals. Decomposition, recycling nutrients back into the soil. So we have harmful bacteria that causes disease, and we have good bacteria, the normal flora in our intestine. You as a researcher are no longer just students. You are a rapid response team. In today's world, it is important for us to work as a team, not individually, but as teams. Because as a team, we use AI tools in order to come up with the results. A patient life depends on our decision. Using AI here is not a shortcut. It is a tool for data analysis and accelerated decision making. Observe the differences between gram-positive and gram-negative bacteria. Here we have the gram-positive bacteria, which is stained by crystal violet, and the gram-negative bacteria, which is not stained by crystal violet. It is stained red by the safranian red stain. The gram-positive bacteria is called positive because its peptidoglycan thick layer, it traps the first stain, the crystal violet stain, while the gram-negative has an outer lipid layer which is easily removed by the washing step with alcohol. Even for 10 seconds it will be washed away. The lipid layer will be washed away with the crystal violet, and the bacteria will be transparent. Then we add the safranin color in order to stain it with red. Your job here is to understand the scientific foundation or the scientific differences between the positive and the negative. Then we can use the AI tool in order to stain the bacteria in virtual lab. First, we use virtual lab in order to stain the bacteria. In virtual lab, we have several application or AI virtual labs that we can use to gram stain the bacteria or for the gram staining process. Today I use this. You can see it here. We go to this lab. Once you click on module, the process will begin. Once you click start, you can see the loop is being sanitized, and then a bacteria is taken from the broth and added to the slide, and then we sanitize it again. Then we use these stain. First we add crystal violet, followed by iodine and alcohol, and then safranian. Then we wash the slide on the microscope. Now, the procedure in real life, on a real world, also it's the same. The same steps. We use the same steps. First, we add a crystal violet stain, for 60 seconds, leave it for 60 seconds. Then we add iodine to enhance the crystal violet stain. And then we add alcohol or wash the slide with alcohol for 10 seconds. 10 seconds only. And then we add the safranium. The safranium here is to stain the gram-negative bacteria with pink color. And we leave it for 40 seconds or 50 seconds. After that, we use our microscope in order to observe the results. Once we see the results, we grab a picture of it or an image of it, and then we upload it into another program. You see we have Teachable Machine. In Teachable Machine program, you can train the AI to read your results, which is actually amazing. Here you can see it. In this program, we train it in order to read our results. Once we upload some images, for example this one, we add an image for gram-positive, and we teach it that this slide represents gram-positive because of the crystal violet. This is a gram-positive rods. Once we train this program into the gram-positive and the gram-negative and the shape of the bacteria, it will read the result instantly, and there is no need for the memorization of the characteristic feature of bacteria anymore. You have AI tools. Then we also can use some other tools. For example, we can ask AI to generate a code for us, and this code represents the gram staining process. Here I use the CodePen program and generated a code. Now the code I used here, I asked it specifically to do the timing correctly. Now if a student did not enter the correct timer for alcohol washing, the stain or the slide will not appear correctly for them, or the microorganism will not be stained correctly. First we add crystal violet, then we add iodine to enhance the crystal violet stain, then alcohol, start alcohol and we do the washing stain. You see here only one bacteria did take the crystal violet and the other one was washed by alcohol. Why? Because this one is a gram-negative. Due to the lipid layer on its wall, the crystal violet was washed away with the lipid layer or the lipid outside layer. And then we add safranium, and here you can see the crystal violet or the gram-positive bacteria and the gram-negative bacteria stained with safranium. Now this is a success virtual lab, or a success gram staining procedure in virtual lab. Now each group consisting of 4 or 5 can assess the result of other group and write their notes. On each group will write a note about the code or about the results of the procedure or gram staining of other group. In conclusion, how will AI change the way we detect bacteria by the year of 2030? The lab is not just a place for tools. It's not just a place where you can find tools and use it. No. It is a place for minds that commands the tools. We use AI. We command the AI to do what we want him to do. We will not use the tools. We will not use our hands only. We will use our minds. Today we stain by hand, but tomorrow robot might stain for us. By 2030, we may have smart sensors. We will move away from manual staining toward electronic noses that detect bacteria by smelling the gases or the compounds emitted by some bacteria in seconds, which would help will help us to identify bacteria faster and identify its antibiotic faster and treat the disease even faster. And in the end, I say thank you. Thank you very much for your listening.